Good afternoon. Thank you for joining us. This is Scott Dahman, Director of Business Development at PowerWorld Corporation. And today we're going to have a presentation from PowerWorld co-founder, PowerWorld Corporation co-founder, and original author of PowerWorld Simulator software, Tom Overby. As many of you probably already know, Professor Overby is at Texas A&M University right now, where he is the O'Donnell Foundation Chair 3 in the ECE department. Prior to joining Texas A&M University, he was a professor at the University of Illinois at Urbana-Champaign, which coincidentally is where PowerWorld is located. So we were incorporated when Tom was a researcher here. He's got a BS, MS, and PhD, all in electrical engineering from the University of Wisconsin in Madison. Before joining academia, he was employed at Madison Gas and Electric, where kind of the seeds for PowerWorld Simulator were started. And lately, Professor Overby has been doing research in the area of using weather information in power system analysis. And he's been doing, his team at Texas A&M University have been kind of looking into different aspects of that. And today he's going to put on his PowerWorld hat and then dive into how you can actually apply the available information on historic weather into PowerWorld Simulator for analysis. With that, I'll turn it over to Tom. Oh, one other thing too. You probably got a notice when you join the meeting that it is being recorded. We will post it afterwards. But if you don't wish to join the meeting because it's being recorded, then you can leave if you like. I will say that pretty much everybody's going to be anonymous unless you speak up. And please keep yourself muted. If you have questions for Professor Overby, please put them in the chat. If you're unable to use the chat or whatever, at the end of the presentation, you can unmute yourself and ask a question when it's appropriate to do so. So with that, I'll turn it over to Professor Overby.
Okay, thanks, Scott. As he said, I'm Tom Overby, and I'm at Texas A&M University. The goal of this presentation is to show you how you can start using weather information in PowerWorld today. We've got weather data available going back to 1940, and actually we're now posting forecast information as well. I did do a presentation on modeling weather in power systems on January 24th, and this one builds on that with more of a PowerWorld focus. The slides from the earlier one are available at the website given there if you want to see that one. So this is not a duplicate of that. This is, it's certainly related, but it builds on that. It has much more of a PowerWorld focus. As Scott mentioned, I'm a professor here at Texas A&M and have been teaching for 33 years, doing a lot of research projects, advising a lot of students. But I've also been involved with starting a company called PowerWorld. The code that became PowerWorld, I started developing when I was a graduate student, continued working in that through grad school, and then I came to the University of Illinois. And about 94, 95, it got to a point where we thought this could be a commercial product. So I talked to Mark Laufenberg, who was a grad student, and said, hey, Mark, what do you think about forming a company? And he was gung-ho on it. So the four of us pictured there formed PowerWorld. Since universities encourage their faculty to be involved in consulting in external business relationships, I've continued to be involved with PowerWorld during the time I spent at Illinois and now at Texas, and actually do work some on the PowerWorld code and have done work on the OPF stability visualization, GMD, HMP, and now weather. Okay, so over the last 18 months, PowerWorld has gained a lot of weather capability. And as of today, we can load weather into simulator. This is primarily through something known as a PWW file, which I'll talk about, but you can also use aux files, and a little less conveniently is the CSV file. We have then got weather data going back to 1940, and we keep that up to date. So it's about five days out of date, and I'll talk about the details of that. And we have recently started adding in forecasts, which are hourly up to 16 days in the future. So the weather data is there, but of course, as power engineers, we don't just want to know the weather, which we can get from many sources, but we want to know how does that weather affect the grid. To do that, we've developed a modeling methodology that we call the PFW models. These originally stood for power flow weather models, but we really have got thinking and saying they're really just general ways of taking external data and relating it to power system quantities. So we kind of call them the power flow whatever models. An example of this is to say the output, the maximum megawatt for a generator, wind turbine generator, depends on the wind speed, or a solar depends on, how much irradiation we're getting. Or if you've got a line, you might have temperature dependent limits on it, or there's other things that we're working on as well. Then we can apply them either in the time step simulation, or you can also apply them on demand in other applications like power flow, and I'll go through the details of that. I will say a lot of this functionality is new. It is only available in version 23 of PowerWorld, and you actually have to have a more recent version of PowerWorld. So if you have 23, PowerWorld issues patches every once in a while, actually pretty often. And if you go to Window About, it will tell you your build date for simulator in the About box. You really need to have a recent one, like late January or February. And of course, we're working on adding new functionality, so just stay up to date. And I will say we very much want your suggestions on what should be included moving forward, and I'll talk more about some opportunities at the end of the presentation. When we started this, we knew about historical weather station information. A lot of these are measurements taken at airports. They're identified by what's known as ICAOs. Those are the four-letter abbreviations that most of us know for airports, like the one in Little Rock is KLIT, the one in College Station is KCLL. So we started using that, and they do give you lots of data, but they also had a lot of missing values, and we only had surface wind values, and we didn't have direct solar measurements. So when we talked to our atmospheric science people here at Texas A&M, they said, you should really be using the ERA5 data. ERA5 data is what's called fifth generation reanalysis of global climate and weather. It is publicly available. It's kind of like a state estimation for weather, because they take the measurements and they couple them with models, and then they come up with a consistent data set for the weather worldwide. They do it on a grid. It's on the data we're using right now is on a 0.25 degree grid. And then it includes lots and lots of different fields. And I'll go through the ones that we use here. And it's put out hourly, and it goes back to 1940. It is updated about 5 days behind real time. So we have scripts that go out and grab the latest and then combine it with the models that we already have, and we post it online. In doing this, and the website where it's at is given there. We've got it on a Texas A&M website right now. In doing this, we tried to figure out what sort of footprint of weather should we get. If we got the whole world, that would be a lot of data. And we decided, okay, we'll start with North America, and then we kind of arbitrarily define North America, or our part of North America as what's shown in the box there on the right. That has 38,497 data points. So we get per hour 8 values. So that means we have about 220 megabytes of data per month, or about 225 gigabytes in our total set. This data is public, and it can be used freely, and you can easily download it. You could probably download it this afternoon. Okay, if you go out to the electricgrids.engr.tamu.edu weather data page, what you will find is there's a box that says view available weather for download. That's where we're placing this weather, and we tend to put it in what's called, or we put it in PWW files, which I'll talk about in a second. And then we keep one we keep one like continually updated. Right now we're doing North America 2024 underscore Q1 for the first quarter, and we update that kind of daily. And then we've got the historical data going back to 1940 in zip files. These you can just download. We download them by decades usually. I tested one on my home computer and it took about 4 minutes to download, so I could get all of our data. I do have a good internet connection at my home, but I can get all my data in about an hour, all the data. So most people probably don't want all of North America. If you're a utility here in Texas, you probably just want Texas data. So we came up with an easy way to reduce the scope of this. We supply North America because it's a consistent way to do it. But there's also a tool in PowerWorld that lets you take the PWW files for North America and reduce them. Right now, you reduce them based upon a geographic rectangle, and then you can store the reduced ones. If we get interest in this, we will do other footprints. Right now, we are actively maintaining a footprint for Texas because I'm with Texas A&M, so we maintain Texas. The Texas grid is 2,679 data points. All the data for Texas is 360 megabytes. It's actually smaller than that when you zip it up. I'm sorry, all of the data for Texas is 15 gigabytes, but it's smaller than that when you zip it up. So you can download Texas pretty fast. Once you have this, PowerWorld has been modified to have tools that make it easy to see weather in lots of different ways. In PowerWorld, in bold here, I'm kind of showing the PowerWorld commands. If you go in the main menu to Tools, Weather Models and Information, there's a page called the Weather Stations page. What you can do is you can use this to view weather for any valid time. Now, what you need to do is, of course, have gotten the PWW files. So one of the fields on this page is a directory where you place the PWW files. For example, on my computer, I've got all of North America. And then you just enter the desired time that you want. You just enter the desired time that you want. I should say in doing weather, all the times that we use with weather are the UTC times. So they're, coordinated universal time. That avoids time zone issues. You can use your local time zone if you want, but in getting it, usually we'll just use a UTC time. So here in the central time zone, now we're -6 off of UTC in terms of hours. And then you just click just get weather for desired date. It goes out and it parses through the PWW files and finds the hour that you're interested in, and then it displays it for you. I should emphasize, in using this tool, your PowerFlow case does not have to have geographic coordinates. You can still get weather even if you don't have geographic coordinates for your case. Now, it's better if you have coordinates for your case, but you can use it without. On the ERA 5 data set itself, it has hundreds of different values. If you're familiar with weather modeling, they model surface values, but then they model different layers going up throughout the atmosphere. We just grab 8 of them right now. We grab the surface temperature, the surface dew point, the wind speed at 10 meters, the wind direction at 10 meters, the wind speed at 100 meters, the cloud cover percentage, which takes into account all the layers. Then we get some solar values. We get the direct shortwave radiation at the surface, and we get the direct we then get also the surface shortwave radiation downward. These are used to get the values we use with our solar PV models. You can also then derive values like humidity. We have like wind chill, heat index, stuff like that. We might be getting more data, as we get feedback from people have suggested we get the 10-meter wind gusts or we get icing estimates. So we might do that, but currently we just get the 8 of them. The PWW files themselves are just binary format files. They store the weather information in a very compact form. They can store either uniformly spaced data, which is typically what we do with the ERA5 data hourly, or then as we got into the forecasts are hourly for like the first 5 days, then they're every 3 hours for the next group of days. So we can store non-uniform hour or non-uniform time data. The measurements are for ERA5 are on a grid, but they don't have to be on a grid. The PWW format is pretty general. The header information gives the file's time range and geographic range, so you can parse through it. PowerWorld can parse through it pretty quickly. The format is going to become public, but currently it's just available upon request. So if you want the PWW format, I can send it out, but I do have some students here that want to publish some of the work that we've done, so they'd like to get that published before we too broadly distribute the format, but it's available on request. Then visualizing the weather, PowerWorld has relatively new spatial data contours that we added for some GIC modeling, but we also use them for weather. These visualize data using the PowerWorld contours, but you don't have to have power system objects on the one line. They actually just are based on the underlying geographic coordinates. And that makes visualizing them such that you don't have to have geographic coordinates in your power flow case. To help to help people make nice looking contours, we've actually made a few. Yeah, Scott just kind of put that line on there. Scott posted them out in the knowledge base. They're just PWD files. We're probably going to make some more. So we made up some nice ones with nice color keys and stuff. And then we're like, oh, we should give these to people. So they're out there. I will say people have asked us about whether we have offshore data. ERA5 is both land and ocean. So we do have offshore data in these files. Although usually when I visualize them, I just do it in a contouring sense that we don't show the water data or the data in the oceans, but you can. So I was thinking, oh, what if I give an example? I was like, well, what's a good example? I thought, well, let me find the coldest day in Seattle. So I Googled the coldest day in Seattle, and evidently it was January 31st, 1950. So I quickly typed that in, and poof, all the weather data is loaded up in about a second. Because I had the PWD defined, I got this nice contour made up. If you want to know the individual values, there's lots of ways to see individual values. In the new contours, there's actually a color key panel that you can show. And then as you kind of mouse around on the display, you can see the values of the contour underlying it. So if you went around the Puget Sound area, you'd see the temperatures. There's lots of other ways to see them as well. Here's an example where I took one of our PWD1 lines and I showed the ocean values as well. This is contouring the 100-meter wind speed for that 1950 day. We'll probably get some PWDs predefined that do this. Usually when we're showing power system information, we don't want our contours to go into the ocean, but of course with weather data, you want to see the ocean sometimes. Then one feature that we added is if you find an hour that you really like, you can easily save the weather data for that hour in an aux file. If you go out to that page that I showed you about where you get the weather data from, there's a button that says Save Weather to aux file. This allows you to save weather for a particular hour into an aux file. So if you want to use it in the future, you've got that weather file. If you want to get a lot of data, and a lot of times when we're doing analysis on this, we're looking at the whole data set. So we kind of analyze 1940 going up to the present to look for outliers, wind droughts, solar droughts, things like that. You can, in the tools time step simulation, that has a lot of weather capability here. If you just open up tools time step simulation, there's a button called read PWW file, and that just lets you read a particular PWW file. For North America, we tend to store, we are storing the data by quarters, so you can get a quarter, calendar quarter worth of data. For Texas, we store it for every 2 years, so you can easily get 2 years worth of data and look at it in the time step simulation. This is like any other PowerWorld case info grid, so you can easily plot the data or export it. If you want to see the weather, all the weather data at a particular location, you just right-click on the desired column and click Show Dialog. Since the Era 5 data is on a lat-long grid, I picked up the data for the latitude-longitude point closest to Seattle, and then you can see it there. I've got temperature and dew point and humidity and values in centigrade and the wind speed, and I've got some of the solar values. That's all available and it's easily accessible. You can then, of course, plot it. Here's a plot of the temperatures for the Puget Sound area during that first quarter of 1950. There's a plot of the daily global horizontal irradiance, and the spikes there are the daily values, of course, going up and down to 0 at night. If you would like to visualize time varying data, there's lots of different ways. Well, I mean, there's one main way to do it. This is something that we do quite a bit of here in our research work. If you go into the time step simulation, you look at a time point records, you can apply any time point, and there's an option to apply it and update the power flow or just update the weather. There's also, I guess the arrow got stuck behind the time step simulation there. But on the time step simulation page, there's a button called Show Stored Solutions Playback Control Dialog. If you go in there and you open it up, it will sequentially go through a whole bunch of data points, and it can store either JPEGs or PNG files, and then you store them as a sequence of files, and then you can use image software to create nice movies. We've been recently using Adobe Premiere Pro here, but there's certainly lots of different packages that you can use to create movies. I don't have an example of a movie here, but they're pretty straightforward to create. Then we were thinking, well, we've got historical data, but we need to get forecasted data. So we were looking at where we could get forecasted data. Thankfully, NOAA has something called the National Centers for Environmental Prediction. It's called NCEP. And they put out forecasts every 6 hours, and their worldwide forecasts on a 0.25 degree resolution, and they go out for 16 days. They're hourly for the first 5 days, and then they're every 3 hours. What we've got is we've got code that goes out there every, I guess, 6 hours and picks up the data, and then we parse it into a PWW file, and then we post the PWW file on our website. I should say, when we started doing this, the website locked us out because we were hitting it too often. And then we sent them an email, and they told us what to do. And they said, look, don't be continually hitting us. Just hit us like every minute or something. So we are hopefully playing nice with them now, and they're not locking us out anymore. The goal is this is now automated in a script. So the goal is, if you go out to the website, you'll have a forecast that was run in the last 6 hours. The bottom here is the format for the files. It says forecast North America run 2024-02-07. What that means is it was run on February 7th. And then the T is the time, we just give hourly, so it was run at 6 o'clock. And then the Z is this is a standard, is ISO 8601 format. The Z indicates that it's in UTC. So that central time was run on midnight between the 6th and the 7th. And then it goes out for 16 days. So the PWW file will contain data for 16 days. Here's an example. As I was making up these slides, I took that file and I just went into time step simulation and I loaded it into the time step simulation, plotted out the average of all the North American temperatures. You can see their number of valid temperatures. The data sets use the same 0.25 degree grid, so we're still getting about 38,500 values of each type per hour. So I plotted out the average, and then I plotted out the College Station 100-meter wind forecast going out for the next whatever it is, 15 days. I just made these up using PowerWorld's quick plotting tool. The quick plotting tool has been enhanced over the last couple of years, so now you can customize it more. And if you want to change the background color, which I did in the bottom right, you can change the background color as well. Here's an example of what the forecasted winds were for February 14th and the forecasted solar at noon. This was made 7 days ahead, so I don't know how accurate they are. I guess I could look out the window to see how accurate they are on the cloud cover. We're just using standard forecasts. We're of course not forecasting any things ourselves. We're just getting the data from the NOAA site. So the forecasts are as good as any forecast. These forecasts don't have the irradiation values. So what we do to estimate the solar output is we guess it from the sun, or we estimate it from the sun's position, and then use the cloud cover percentage. And not perfect, but it is certainly better than nothing. If you want the current weather, there is a way to get the current weather. If you go out to that website there, you can get the current weather. It's based on MEDAR data. So if you look at the lines there, they're the ICAO reported values for the particular hour. PowerWorld can parse in this file. PowerWorld does not automatically download this file because we know customers are sensitive about having PowerWorld software going out to the web, which they certainly don't want. So if you want to get it, you have to get it from that website. But then once you've got the CSV file, you can go to this page here, which is the same weather stations page that I showed before. And I guess this one's a little blurry, but you can just load in. There's a button there that says load the CSV file. Then it loads the CSV file. The one that I got on, I think this was February 7th, it had data for 4,669 stations, but not all those stations had valid data. This is a contour I made of the wind speeds. I guess I did it for February 10th. This is a PowerWorld contour, and then I used geographic data views to put the arrows on there showing the wind direction. That's just current data. So probably a better approach is to use a forecast, but if you really got to have the current data, that's available as well. Okay, so what I've talked about so far has been getting the weather, and the takeaway is the weather is available. We are maintaining it. Texas A&M is maintaining it on our website. You go out there. It's stored somewhere in the cloud, and hopefully there won't be any issues with downloading it. I guess it's on a Google Drive right now somewhere, but we might be switching that around to get better availability. But takeaway is the weather's available, but the focus here isn't the weather, it's modeling the impacts of the weather on the grid. So what we need are the models that relate the weather to grid components. And what we are doing is, when we were talking about this at PowerWorld, trying to decide, well, how do we do this? We have a lot of experience in implementing stability models. And stability models, of course, transient stability, or the dynamics models, they've been around for a long time. And when stability models started out in the early 60s, there were just a handful of models, whereas now we end up supporting hundreds of different model types, and they seem to be growing every day. So we decided, since we already have a software methodology to handle these sorts of models, why don't we just leverage this in the PowerFlow? So we decided to create kind of I don't know if I'd say it a subset. It's certainly akin to the stability modeling. We use actually a lot of the same code that we use to model the stability models. And we just decided we'd call them PowerFlow weather models. And then again, as I said, they can be generalizable. They don't have to be weather necessarily. So we called them PowerFlow whatever models, but the acronym is just PFW models. Here's an example. As we started going on this, we thought, okay, we need a model that tells us what the maximum megawatt for a wind turbine is based on the wind speed. And since NREL had put out curves, and the curves were based on class 1, class 2, class 3, we just coded up their curve data and have generic PFW models that take as an input the wind speed at a particular location. And then one of the parameters is the max megawatt values for the wind turbine, assuming it's running at full blast. And then we can calculate, we model the speed, the power speed curve here, and it's based on the class. We recently, I guess it's on the next slide, we recently implemented a new model, which we call the wind general model, and that's similar to these wind class models, except as parameters, you can enter in the power speed curve. So you enter what is the speed, what is the power, normalized power output at 2 meters per second? What is the normalized power output at 3 meters per second? And you just go up, and they're just like any other parameters in a stability model, that PowerWorld has a lot of support for handling those sorts of parameters. So you can custom define your models based on the particular wind speed characteristic at that location. We did set it up so that there are easy ways to enter a lot of models. If you wanted to get started on this and you just knew for your generators which ones are wind turbines, if you just assigned them all to a class, like to the wind class 2, that would be a place to start. And there's ways where you can take a whole display of all the generator models. Here I've got them sorted by fuel types. I just select them all, and I type insert new PFW models, and it will insert default PFW models for those generators. To make it easy for people that just want to get going on this, or maybe you're an academic wanting to have access to real U.S. generation information, the U.S. Energy Information Administration, EIA, puts out the form EIA 860 datasets. I should say that EIA was one of the early PowerWorld customers. So in the early days of PowerWorld, we worked quite a bit with the people at EIA. So we very much appreciate the support they've provided to PowerWorld over the years. But their primary goal is to put out energy data, and the EIA 860 data has information on every generator in the US with 1 megawatt or more capacity. The website there is posted. It's released yearly and updated monthly. What we decided to do is actually to create a PowerFlow model based on this data. Now, we call it a PowerFlow model, but it's not really a PowerFlow model in this traditional sense. It's a copper plate model. So all we're doing is we're setting up substations and buses and generators using the public EIA 860 data, and then assuming there is no transmission grid. So this lets us visualize the outputs of the generators, but of course has no CEII information in it. And it's kind of a cool process. One of our students, Jordan Cook, did this, and she just presented a paper on it yesterday. We had the Texas Power and Energy Conference. If you want to know the details, there's a paper on my website. This is results that we have. These models are available on a website. I guess I gave the website there. We post them. Jordan actually puts out an update every quarter. So we decided we just update the EIA 860 data every quarter. This is an example of that model. The EIA 860 data set actually has for every generator, every wind turbine generator, it's got the wind manufacturer and the turbine model. So, and it tells a wind class, so we can put them in wind classes. If somebody's interested, we can certainly implement PFW models for particular wind turbines. Setting a wind turbine, model, setting up a PFW model is very, very, very straightforward. I mean, we've done this for hundreds of different stability models, and these are much simpler than most of the stability models. So they're literally very fast to set up. So if somebody says, hey, I've got all these blankety blank wind turbines, and you send us the power curve information on them, we could set that up for you. Then the next step is you have to map the weather to the weather's on a grid, and then you have to map it to the location of your power component. There's this is a scattered 2D scattered data interpolation problem. There's a number of different ways to do this. You can use a grid-based approach, closest neighbor, Delaney triangulation, Shepard's approach. Right now, mostly we're using just the closest grid point for a generator. We're actually hoping as we move forward to do a research project working with our atmospheric science people here, where we actually do elevation correction on some of this data. All the ERA 5 data points have an elevation associated with them as well. So if we're getting the wind at a particular elevation, I mean surface elevation, and you want to know something on a mountain, we might be able to do something for you. We hope to work with our folks in the atmospheric sciences department at Texas A&M. Here's an example. I know in some places closest neighbor works quite well, like in Illinois and Texas and kind of the flat parts of our continent. But in the Pacific Northwest, you got more WCC, you got more variation. This gives you a feel for what a 0.25 degree grid looks like on the states of Washington and Oregon. It's pretty good, but it's maybe we'll do something better. ERA 5 actually puts out a 0.1 degree data set that is just for the land, and we are probably gonna post the 0.1 degree data sets as well. Of course, when you go from 0.25 to 0.1 degree, you increase the number of data points, so your file sizes get bigger. But in some places, that additional resolution might be important. So what we wanted to do is we wanted to get the 0.25 degree and the forecast data running, which we've done. So now we're going to probably go back soon to get the 0.1 degree data. Then in applying the weather, there's lots of different ways that you can do it. You can apply weather at a specific point in time. You can summarize a large amount of weather at a single location or a few locations, perhaps a transmission line, or you can actually process the weather as time series. The next few slides demonstrate this on some of our displays. If you want to apply the weather at a single point in time, I showed this earlier page. It's tools. Then you go to weather. The weather box is kind of over on the right there, and you then you can either where the top arrow is, you can just apply the weather to get the desired date, or you can get the weather and apply it to the power system, which will go in and actually modify the max megawatt fields for your generators. There we're changing the max megawatt field for your generators, so you have to use this with caution. When you're done, there's an option to restore the design PFW values, so it puts the max megawatt values back to where they were. But when you do that, you can take on the left here, I've got an image of I I guess this was the weather for January 14th, 2024 at 12 UTC. And the image on the left is not scaled. It does not scale the generation by the wind speed or the solar. On that image, the green ovals are the wind turbine generators, actually the wind turbine generators at a substation, and the yellow are the solar. In the data set that we used here, which was the EI860 that was released in September 2023, we had a total of 144 gigawatts of wind and 82 gigawatts of solar. When I applied the weather to it, which is straightforward to do, you can see that it reduced that to 85 gigawatts of wind and only 3 gigawatts of solar. The reason why the solar is quite low is because that was at 12 UTC is 6 a.m. Central Time, so the sun had not rose in most parts of the country then, and there's certainly some clouds. This is one I was talking to one of our staff engineers yesterday, and I said to her, "Hey, can you, for this presentation, can you get me a day that has a lot of wind and solar and a day that has little wind and solar?" And she worked her magic, and very quickly she parsed through all the data sets and out, or we want an hour when the sun is out. So she has code that parses all this data very quick, and she got it to me, and she said, okay, April 29th, 2010, there was a lot of wind and a lot of solar. And actually, on that day, we had 73% of the available capacity would have been running if everything was in service. And then if we go back to September or December 12th, 1941, which was actually only a couple days after Pearl Harbor was attacked, the weather would have been such that we only had 15% of our available solar and wind on that day at noon. And it actually happened to mostly be in Texas. I thought that must have been a really cloudy day. So I visualized the cloud cover, and this is the cloud cover for December 12th, 1941. And just to be clear, we're applying the December 12th, 1941 weather to the generation portfolio that we had in service at the end of September 2023. And of course, December 12th, 1941 is not going to occur again, but the weather pattern that we had on that day certainly could reoccur. So we could have a day where here most of the country's cloudy. It was actually kind of sunny in the middle part of the country, mid kind of towards Colorado, New Mexico, West Texas part of the country. So it actually was a severe day. It would have been a severe day across most of the country, but not particularly severe in Texas from a wind solar perspective. You can get lots of data at a single location. Here's a slide where I went in, and it's very simple to parse through all the data at a single location, particularly if you have smaller PWW files. So just for fun, I grabbed all the temperature data in San Antonio. And there's a graph. It's got 700,000 data points on it. Of course, you can't see most of them because that's much higher than the resolution of the graph. But then I created a histogram of the San Antonio temperatures. I was kind of interested in looking at how cold it gets here in Texas, and because we had just had that cold snap. So I thought, oh, I wonder if it's going to get below 20 again, which hopefully it won't. One application is you can look for outliers, and I sorted that data, and this is a date where San Antonio had its lowest temperature. Of course, you can just Google this stuff too, like I did for Seattle, but here I picked it up off of there. Or you might want to, something that we're doing research on is to find what time periods did we have it where the wind just didn't blow or the sun just didn't shine for a long period of, what we call a wind or solar resource drought. We're working on that. Here, we've added this at the generator location, so you can actually go in and if you look at the far the dialog, the generator dialog, about midway down on the right side, there's a capacity factor. Based on the generator data that I put in, this was for a wind turbine generator, I can calculate the capacity factor I would expect at that location using 700,000 actual weather measurements. And here it was about 39.9, I guess. But if I change the assumed hub height, and initially I assumed a hub height of 80 meters, but if I go up to 100 meters, I increase the capacity factor increased to 44.5%. Running all the time points, in the time step simulation, it's very easy to run all the time points. You just load up the PWW, and of course, you need to load it into a case that has PFW models for it to apply the weather to the case. There, in the time step simulation, we originally developed this to run OPF simulations and security constrained OPF simulations. But if you just want to apply the weather to see what the renewable generation would be doing, you can just change the solution type to weather only, and then it just applies the weather. That solution is very fast because it's not actually solving a power flow. This is an example where I took the data. I think this was the beginning of 2024. I took a case and I looked at what would be the wind and solar output for that historical time period. We've set up here I was using the EI860 model. It's got it for the whole country as a super area, and it's also got it for each of the individual states as a zone. So just for fun, I looked at, well, what would the Texas wind and solar be, and came up with that plot there. This naturally leads to validation. So we're working on validating this, but the validation is going to be dependent upon how good is the PFW model and how good is the weather data. Just for fun, I gave you a cookbook approach here that you can go out and try today if you have a recent patch of PowerWorld. This uses if you have PFW models set up for your actual power grid case, and I should say we've gone through and mapped essentially, well, more than 95% of the capacity in the EI860 data set to the bus numbers used in the power flow for the West and the East in Texas. And we have this data available, but of course that's CII data, so we don't give it out unless we know who we're giving it to. But for this one, I took our EI860 power flow case, which is of course copper plate, and then I went out and got the forecast for today going forward. I selected tools, time step simulation. I read in the PWW file. We have in our EI860 data sets, we actually include an aux file that you can load up that sets up the time step simulation so it stores certain fields. We store the total wind and total solar generation, and then we store the wind and solar generation for each state. You change the solution type to weather only, and you click do run. That's what I did, is I set it up like that. I used a forecast that was run on February 14th at 0 hour UTC, so it was from 6 p.m. Central Time last night. And there are the results there for what I think Texas is going to be doing in terms of wind and solar. I should say we're not saying this is what a utility wants to use. We're not saying that. We're just saying these are tools that are available, because this is, of course, assuming all the generation is in service. So it's not saying this is an operational tool. It's saying this is something that a planner can use if they want to get an estimate of something going forward. But that's what we got for estimated U.S. wind and solar generation from today going forward for the next 15 days. And that's what we have for estimated wind and solar generation for Texas from today going forward, based on totally free public information. We certainly know this is far from perfect, certainly can be improved, and that gets into validation. But the point isn't whether a bunch of academics can run this. The point of this is saying we're giving tools out to the planning or the planning community that they can use however they see fit. And you would obviously have better models than what we have out of the EIA 860 data set. So something going forward is we're working on validation, and this is a slide where we're working on a paper on this. The Farnaz is one of the people who's done a lot of work on this. So we're hoping to come up to Champaign, visit PowerWorld, and present this at the Power and Energy Conference at Illinois. There's lots of additional models that we can implement. For example, PowerWorld's done a lot of work with some of its customers on transmission line limits. They have very sophisticated transmission line limits. All that would directly fit into this modeling methodology. Transformer limits might go in. Load models, we know we could we could do load modeling if we wanted. Line resistance, of course, more generator models. Kind of the sky's the limit on the PFW models that could be defined. And I should also say that as we got going on this, Zach Zorns sent us an email before the October 14th eclipse last fall. And he said, does PowerWorld do anything with eclipse modeling? And at the time, we didn't do anything with eclipse modeling, but because of Zach's interest, he kind of got us started on modeling this. So we're actually setting up a modeling methodology to deal with resiliency events. And eclipse is a very benign event. We had one in October, and of course, we're going to have a total eclipse coming through this part of Texas on April 8th. So we're going to set up an eclipse model for the April 8th one. I was just, that's close to being done. But we're looking for other resiliency events. So if you look and you think, okay, here's an event that we would like to have modeled, its impact on the power grid. It could be weather related. Of course, we've got weather covered, but the ERA 5 data isn't going to pick up tornadoes. So if you said, here's what I want for a model of a tornado, and maybe we set up a PFW model that is a probabilistic model that says, with these wind speeds, if this tornado goes through this location, here's the probability that line will be taken out of service. Or, maybe we'll set up hurricane models. We're certainly, I haven't looked at the ERA 5 data for the hurricanes, but it's certainly going to see hurricanes in the ERA 5 data. This is a visualization we made up where we run it in our time step simulation. We use a time step of 1 minute. So if you've seen the movies I put out, you see this bullseye moving across the country, and that modeled the October 14th eclipse. We're going to have another bullseye moving in the direction going to the northeast to model the April 8th, 2024 eclipse, and we'll get that out to people very soon. Unfortunately, that's our last eclipse in North America until I think like 20 years in the future. So there's limited application for this eclipse stuff, but there's lots of other resiliency events we could consider. So going forward, we are actually working on a project, a proposal. Texas A&M is involved in it, and PowerWorld is involved in it, where we would like to move this work forward. There's many different directions to do this. Certainly, we're going to be increasing the number of PFW models we have. We're going to be looking at the ERA 5.1 degree. There's increased automation, the updating process, more validation. But we're going much beyond that in this proposal. I don't want to get into the details too much here because, of course, this is a proposal that is, we compete with other groups for the proposal, so I don't want to say too much. But we're going to be developing an industrial advisory board for this, and we also need to have demonstration sites. So we would love to have industry partners join the team. I'll be reaching out to some of you, but if you would like to be on the team, let me know. because we would like to have people in, a good industrial team coming in on this proposal. So I'll leave it at that. I should say some of the recent papers are available there. If you have questions, you can email me there. This is our facility we have at Texas A&M where we started doing short courses. We've got a number of short courses coming up. So if all of which involve, well, all of the ones I'm involved that involve PowerWorld software. We've got one on planning. We've got one on dynamics. We've got one on kind of a overview of simulator, I guess we call it bootstrap or something on simulator. And then we've got one on power system basics. So with that, I'll conclude and open it up for questions.
Please feel free to put your questions in the chat, or I can unmute yourself and ask as well.
Hey, quick question. So is there any plan to move PowerWorld into the cloud computing and ability to run that in the cloud?
Somebody from PowerWorld could probably answer that better than me. I think PowerWorld has cloud capability right now.
Yeah, I think it's been tested and done a little bit with is it Azure? I think is the Microsoft version. I don't. Jamie or Mark might be able to provide a little bit more information than I can if they're online. But
yeah, this is Mark Laufenberg. Yeah, we have several customers who are using cloud computing for running PowerWorld. It's not cloud computing in the sense that you can log into a website and run a PowerFlow, but it is cloud computing in the sense that they use either Azure or Amazon Web Services to spin up virtual machines, and then those virtual machines are running Windows. And typically what it's being used for by our customers right now is for massively distributed computing resources. So that's I'm not sure if that's exactly what you meant by cloud computing, but that's the extent of what our customers are doing with cloud computing right now.
Thank you. Yeah, that makes sense.
all right, any further questions? Just to repeat what I said earlier and also posted in the chat, we will take the materials from this presentation and post them on the PowerWorld website shortly. It may take a day or two to process the video and kind of edit out the dead space at the beginning, but we'll get that up as soon as we can. We'll also share Tom's presentation and some other links as well.
Okay, thanks everybody, and let me know if you have any questions on this, or if you'd like to, be a partner with us on some of the things going forward. It's pretty exciting, and as somebody who's been involved in PowerFlow since the early '80s, it's neat to see how all these things are coming together. But it's also challenging as the electric grid becomes so much more dependent on the weather. So we want to be at the head of the curve, and I think we are at the head of the curve in making this information easily available to PowerWorld users.
All right. Thanks, Tom, for that presentation. Thanks everybody who joined. We'll be signing off now.
Thank you. Bye.